question it says that the curve C has equation y equals to x squared minus 3x plus 2, and we have to find the coordinates of any points where C intersects the coordinate axis. So whenever a question mentions the terms coordinate axis, that means we need to put x equals to 0 and y equals to 0. Basically, we're trying to find the x-intercept and y-intercept. So let's start with putting x equals to 0. So when you put x equals to 0, we get y equals to 0 square minus 3 times 0 plus 2, which is going to give us 2. That means one coordinate is 0, 2. And now this is your y-intercept. Now to find the x-intercept, we put y equals to 0. Let me just write this as the y-intercept. So to find the x-intercept, I'm going to put y equals to 0. So y 0 equals to x squared minus 3x plus 2. So let's try to factorize this. So if we use a middle term breakage, we know that the factors of 2 are just 2 and 1. And if we try to replace negative 3x with negative 2x minus x plus 2. Now let's factor by grouping. So if we look at x squared minus 2x, we have x common between them. So x minus 2 in the bracket. And between negative x and 2, we have negative 1 common. So x minus 2 equals to x minus 2 times x minus 1. So that means put each bracket equal to 0. And that gives us x equals to 2 and x equals to 1, which means the x-intercepts are 2, 0 and 1, 0. So these are the coordinates where the curve C intersects the coordinate axis. Now if you look at question number 1b, it says sketch the graph of C showing clearly all points of intersection with the coordinate axis. So we already have the coordinate axis intersection points. So what we're going to do is we're going to draw our axis, label the points. So 0, 2, so 1, 2. This is 1 point. Use a different color. And 2, 0 and 1, 0. 1, 2. 1, 0 and 2 zeros. These are our points. So if we roughly sketch this, it's going to be something like this. If we move on to the next one, it's asking us to write the quadratic function in the form of y equals to a times x plus b whole square plus c, where a, b, and c are integers to be found. What we will do over here is that we'll first write the quadratic equation, which is y equals to x squared plus 8x minus 9. So we're going to use completing square method over here to convert this into the completing square form. So for that, what we're going to do is we're going to write x squared plus 8x together. And I'm going to separate the negative 9 over here. So if you remember the formula, a squared plus 2ab plus b squared. So over here, our a squared is x squared. Our 2ab is 8x. And we have to figure out what our b squared is. 9 is not the b square value. We have to find the b square value. So we have to figure out the b square value. So if we look at the 2ab, which is 8x, we can easily find the b value because a is x and 8 divided by 2 would be 4. So basically b is 4. So what I'm going to do is I'm going to write x squared plus 8x as it is and add plus 4 square, which is our b square value. And I will write minus 4 square as well, along with the minus sign. So the reason why we're writing minus 4 square over here is because plus 4 square is a new term that we're introducing in this equation. And it's a mathematical rule that if you add a new, like introduce a new thing, like for example, if you're adding it, then you need to subtract the same term as well. Like if you remember when in fractions, we multiply the numerator by like a new term. So we divide the denominator, like we divide the numerator by it as well. So applying the same rule over here, if we're adding plus 4 square, we're going to subtract it as well. And now we're going to rewrite it as the a plus b whole square format. So which means a is x, b is 4 whole square. And now the minus 4 square will be outside the bracket. It's not going to be part of the bracket. That means minus 4 square is written as minus 16 minus 9, which then becomes x plus 4 whole square minus 25. So over here, a is 1, b is 4, and c is negative 25. This is your completing square method. Now, completing square method is very commonly used when they're asking us to find the turning points of like a quadratic curve. So turning points are basically use these values. So this is your x value and this is your y value for the turning point. So they're asking us to find the turning point. That would be negative 4 and negative 25. Now the reason why we're writing 4 as negative because the completing square form is y equals to a times x minus h whole square plus k. This doesn't change. It's x, like this format is fixed. So in case the sign in the bracket changes, that means when you write the coordinate, like you would write the opposite sign over there. So if it was, let's say, x minus 4 whole square over here, then 4 would have been positive. It wouldn't be negative. It's based on that. Then in the second part, they were asking us to find the minimum point. So minimum point is negative 4, negative 25, which we have already mentioned. Then third part is to sketch. So negative 4, negative 25 is what we already have. We do not have the coordinate axis. So for that, we would put x equals to 0, we would put y equals to 0. We would find the points and then you would sketch it just the way we did in the first question. Now, if we look at something different, 4b. In the first question, they're asking us to find the minimum value of the function, which you already know we're going to use the completing square method to find. Then it says, hence or otherwise prove that the function has no real roots. So to prove that, we use b square minus 4ac, which is the discriminant formula. So for it to have no real roots, your b square minus 4ac value has to be less than 0. So b is 4, a is 1, and c is 5. Substitute the values. 4 square minus 4 times 1 times 5. 16 minus 20, which is negative 4, and that is less than 0. So yes, it has no real roots, and we have proven that through our calculation as well. In question 5, it says that the function kx squared plus 2kx minus 3 has two distinct real roots. Show that k is less than -3 or k is greater than 0. So for this, what we're going to do is we're going to find the discriminant. B squared minus 4ac is going to be greater than 0 because it has two distinct real roots. So b value is going to be 2k, which is the coefficient of x. A value is going to be k because that's the coefficient of x squared, and c is -3. 4k squared plus 12k. Factorize this, 4k is common, so 4k brackets k plus 3. So whenever we have discriminant and we have like quadratic inequalities, what we will do is we'll roughly sketch the curve. So one point is 0 and the other point is -3. So this is our graph for this. And it says greater than 0. Since it says greater than 0, that means we look at the values of k above the axis. If it was saying less than 0, then you would look at the values below the axis. So if we look at the value at x equals to -3 or k equals to -3 in this case, value is decreasing in this like on the left hand side. And at k equals to 0, your value is increasing. So k would be greater than 0 and k would be less than -3, which is what we had to show in this. Question 6 says the equation 2x squared minus 4x plus 3 minus 2k equals to 0 has real roots. Find the possible values of k. So now in this case, it has real roots. So when we have real roots, b squared minus 4ac would be greater than 0. b is -4, a is 2, and c is 3 minus 2k. So that's going to be 16 minus 8 times 3 minus 2k. 16 minus 24 plus 16k. 16 minus 24 would be -8. Take the -8 to the other side. So 16k greater than 8 and k is greater than 1/2. The equation y equals to x squared plus bx plus q has no real roots. Show that p squared is less than 4q. Since it has no real roots, that means b squared minus 4ac is going to be less than 0. B is p, so p squared minus 4. A is 1, and c is q. P squared minus 4q. Take the 4q to the other side, and you have your